In this lesson, we're going to discuss the limits of difference quotients. Given a function f of x, the difference quotient is defined as f of a plus h minus f of a over h, where x equals a is a value that's in the domain. The first thing that we need to talk about is how to evaluate the difference quotient. The first thing we need to do is find what f of a plus h is. Then we need to find f of a. We're going to find the difference between the two and then divide that result by h. So basically, I'm just following my order of operations here. So if I'm given f of x equals x squared minus 3, I want to evaluate the difference quotient. So the first thing that I need to find is f of a plus h. F of a plus h, we're plugging in a plus h for wherever we see an x. So we have a plus h squared minus 3, which we can simplify. A plus h squared is a squared plus 2ah plus h squared minus 3. The second step is to find what f of a is. Well, f of a is equal to a squared minus 3. Next, we want to subtract the 2. So I can do that very easily right here. A squared minus a squared, well, those are going to cancel. Negative 3 minus a negative 3, those are also going to cancel. So I'm left with two ah plus h squared. The last step is to then divide by h. So this, remember, is f of a plus h minus f of a. Dividing this by h is going to reduce all these powers of h by 1. And I'm left with 2a plus h. So again, what did I do? I found what f of a plus h is by plugging in a plus h wherever I saw a value for x. I simplified that, so I just multiplied that product out. Then I found what f of a was, subtracted it from the f of a plus h, because again, that's what is in the numerator of my difference quotient. And then I divided that result by h. So 2a plus h is my difference quotient for f of x equals x squared minus 3. In this example, I want to find the limit of this difference quotient. So if I'm given my x squared minus 3, we want to find the limit of the difference quotient as h is approaching 0. So the limit as h is approaching 0 of 2a plus h, which was our difference quotient, well, our limit is only with respect to h. So we have, if we use our substitution rule, 2a plus 0, which is 2a. So the limit of my difference quotient, where the function is x squared minus 3, is equal to 2a. In this next example, if I'm given f of x equals 4x minus x squared, we want to find the limit of the difference quotient as h is approaching 0. So the first thing that I need to do is I need to find what the difference quotient is here. So I'm going to find f of a plus h, subtract it with f of a, divide by h, and then find the limit. So f of a plus h is equal to 4 times a plus h minus a plus h squared. When I distribute the 4 and multiply the a plus h squared, I'm going to be left with 4a plus 4h minus a squared minus 2ah minus h squared. Next, I need f of a. F of a is 4a minus a squared. I'm going to now subtract. 4a minus 4a will cancel. Negative a squared minus a negative a squared is going to cancel. So I'm left with f of a plus h minus f of a equal to 4h minus 2ah minus h squared, which I now divide by h to find the difference quotient. When I divide by h, remember we're just reducing every term by 1 power of h. So the h here cancels, the h here cancels, and this lowers down by a power of 1. It's the same as if I factored an h and then canceled out the common h's in the top and the bottom. The same idea here. So my difference quotient here is 4 minus 2a minus h. The last step here is to take the limit of that difference quotient. So the limit, as h is approaching 0, of 4 minus 2a minus h. Again, the only thing that we're concerned about is the terms that have h in them. The other terms, they stay the same. It's just like pretending a is the number 5. It doesn't really matter what a is, because we're only taking the limit with respect to h as h is approaching 0. Well, as h is approaching 0, we're going to be left with 4 minus 2a. So that's the limit of my difference quotient here. Difference quotients are used a lot in calculus when we start talking about the idea of derivatives. So we introduce it with our limits, since really when we talk about derivatives and we talk about rates of change, we're going to start off by looking at the difference quotient.